detection model before deploying it to the Jetson as a CUDA code. So I'm going to be talking a lot about the image labeler app that comes with MATLAB, because labeling images is the biggest bottleneck, right? So usually you have thousands of images that you want to label, and you have a really short time to do that. So if you're in a competition, you have a few days that you have to get it all labeled and then train your detector. And with 23B, the image labeler app allows collaborative labeling, which allows multiple people in your team to label images at the same time. This vastly decreases your time to label images. And we also provide inbuilt and custom automation functions to save time. So let me switch to MATLAB so I can show you how this really works. So I'm going to be opening up my live script here. So the data that we have for this webinar is provided by the Embry-Riddle University. This was taken in one of the previous RoboSub competition, which has a bunch of buoys, as you can see, and a navigation gate that the submarine has to go through. So these are things that you have to detect with your camera. And in this webinar, we're going to be talking about how you can detect them and how you can deploy it to your jets. So this, I'm just reading 4 random images from the data set, which shows the object that we're trying to detect. And then we'll talk about how you can use the labeler app to label these images. So the collaborative labeling app has a structure like this, where the project owner takes ownership of the whole project and then distributes tasks to all the different task owners. So the task owners will usually be your teammates, right? People who can label these images. So if you have 5 people and then a project owner, you'll be distributing these tasks to all these 5 people. And then you can see the progress that they are being made. So let me open the image labeler app to show you how we can do this. So you would start, full screen. So you would start a new team project. And the first thing you're going to do is import the images, right? So I'm going to click on import, choose from file. And I have a data set here that, like I mentioned, was provided by Embry-Riddle. So I'm going to choose images that show the buoys a little bit so we can see how the detection algorithm performs. So this one seems to show the buoys. I'm going to use this. I'm just going to use about 20 images for demonstration purposes. Then we're going to add team members. So there's an option to add your team members. Let's say I have 3 team members named Jack, Josie, and John. So once you add these team members, I'll close this window and then add label definitions. So these are definitions of your label. You have not started labeling yet, just defining what the labels are. I'm going to start with a green buoy. And then you're going to have another rectangle for a red buoy. Yep. And then you have the final one, just yellow, I think. Yeah. So I'm going to start oops, sorry. This happened. Yeah, sorry about that. You have yellow buoy. So once you have these labels defined, the next step is to assign tasks to each of your team members. So you can do that by clicking on Add Label Task. Click on that, and then you can add multiple tasks and distribute images, which will automatically distribute the task among the 3 members. So I'm going to choose 3 because there are 3 people in this group. I click on Create Task, and that would create 3 tasks, and then it's going to split these images among those 3 people. So since this has 19 images, it's split into 6, 6, and 7. And for each one, you can choose the owner. So I'm assigning this to Josie. Oops, sorry. My light just went out. And this to John. So once you have all of this assigned, you can now publish all the tasks to your team members. So I'm gonna save this as multi-user label project. You can give it any name, but the only condition here is you save it in a folder in which all the members have read and write access. So you need your team members to be able to read this folder and then make changes to them. So I saved that, and you give you once it's published, you get a link which you can share with your teammates. So if I was one of the teammates, what I would do is in my PC, let me close this one. My PC, I would open the image labeler app again. I'm just going to apps, opening the image labeler. And instead of creating a new project, I'd be opening a project. Um, I'll have the one that I just saved and then open that project. So I'm going to choose task owner here. And let's say I am Jack. So I know that I have 6 images that needs to be labeled. So I can open them. Takes a second to load these images. Once these are loaded, you can start labeling them. So if I click on green buoy, I can start drawing the labels around these buoys. And then once you're done, you just mark image as label. So typically you have thousands of images. So in this case, I just have what is it, 6 images that needs to be labeled. But in case you have, let's say, 5,000 images, what we typically recommend is first take like 500 images and then give it to your teammates, have them labeled, and then train a network. It doesn't have to do well. It just has to detect decently well with the 500 images that you provided. So once you have a detector that can detect to a reasonable accuracy all these buoys, you can then use one of your own custom algorithm to automate the rest of the labeling session. This way you save a ton of time. Let's just zoom in, zoom out a little bit. You can save a ton of time by not hand labeling all the 5,000 images. So for this demo, I have a pre-trained network that can detect buoys. So I'm going to use that to automate my labeling. We do have some inbuilt automation functions which can detect vehicles and people. So we chose this because this is usually what people um, detect in some of applications that we have seen. So these are the two commonly requested features. These are inbuilt, but in this case, obviously, this is neither a person or a vehicle. So we're going to use a custom automation function, which is derived from that model that you would train with, let's say, just 500 images. So you take a custom automation function, and then you click on automate. Okay, so just a second. I'm gonna have to mark it unlabeled first. So I'm gonna give automate. Sorry, it select all the images. So I'm gonna select all the images and then click on automate. So now I'll be using the custom function that I have defined. It's called the my automation function. I'm gonna use that. Um, Once that is done, let me show you how that function looks like as well, so you know what I'm talking about. So this one is just going to load a previously trained network that I mentioned before, just train a basic network with 500 images. I used a YOLO V2 model for that. You can use whatever model that you want, have it detect the objects, and then populate them to a structure which has 3 fields, uh, which is the name, that is the label that you want to give to that object, and then the type, if it's a rectangle or a circle, and then the position of the bounding box. So once you have this function, you can go to your labeler app and then click run, which should provide you with labels. So again, you can see that it's automated most of it, but it was not able to detect the red buoy here. So you can just add a red buoy manually to these two, and then you have all of them labeled. So you just click on accept, and then you now have all the images labeled. So as you can see, this is a much faster way for you to label these images. And then once all of them are labeled, you just click on, you just go to each image and then mark it as label. So this is again to make this doesn't happen automatically because we want you to take a look at these labels after they've been generated and then mark them once you are sure that this is the right way to do it. Um, so once you have labeled all of them, once you have marked all of them, you can then send it to your project owner. I think this is the last image. So now you just send it, uh, send these labeled images, which would then be updated to the project owner. So let's say Jack's job is done. He has labeled these 6 images. He's going to close it. And as project owner, I'll be opening the same app again. So this will be in the project owner's PC. Select the same project on the project owner. And as project owner, you'll be able to see that Jack has completed all 6 of his images. And then you can also, if Josie and John had done them, you can also see their progress over here. So you can use these images, and then once all of them are done, you can export these labels to Workspace or to a file. But if you want, let's say you want additional eyes to look at these to make sure all of these labels are nice. Again, like I said, your object detection model is only as good as your data. So you need to make sure your data is really good. So for that case, you can add a review task. You can have someone else review these labels. So if I add a review task and then let's say I'm assigning it to Josie, and I'm going to choose these images that was labeled by Jack, add them to the list, and then I can publish this task. So if you want someone else to review the work, you can just add a review task and then publish that. And if Josie was to open her labeler app, she would see that now there are two, she has 2 tasks that she can do. So if I was Josie, I have 2 tasks. One is to label the images that was assigned in the first place, and then a new task that is to review. Let me just open review to show you how it looks like. Right. So we have all the 6 images that was labeled by John, and then you can cycle through all of them, make sure all of them look good. If there's something that you want to be a little adjusted, you can just make small changes and then accept this image. So this would mean that it is reviewed and it is logged. And if you cycle through all of them and you decide that there's no more adjustment needed, you can just click here and then choose accept all and send, which would send all of this to the project owner. So now you can see that this little lock icon has appeared over these images, which means that the image has been reviewed and labeled and reviewed. So there's no one else is allowed to change these images except the project owner if he gives a new task. So this lets you have good control over the data that you're labeling and also have it labeled and reviewed by your whole team instead of just a few people working on it. And you can also do it at the same time. So this helps save you a lot of time, especially with the automation algorithm. We can easily label 5,000 images in about an hour and a half. So that should save a ton of time for people who are time constrained, especially in competitions and in hackathons. So once all of them are done, sorry, once all of them are done, you're just gonna have to send these images. You're gonna export them as labels to your workspace. So let me just go back to my presentation where I'll be talking about training a model. Um, you export the labels and you set up a data as data stores, which is something that MATLAB provides to deal with large data sets. And then you choose your model parameters, starting from what model you want to use. Here we choose YOLO v2, but you can choose any of the models. You can also choose if you want to use a pre-trained model and then just fine tune it, or you want to train it from scratch. You can choose the parameters, other parameters like your learning rate, your optimization function, and your cost function. And then once it is done, you can use that model for the rest of your rest of the webinar. But I'm not going to go much into detail because we have a video that is on model training, which is very comprehensive. Let me just open it to show that it is a 20-minute video that shows how you can train a model and also how you can see, you can evaluate these results. So that should be posted in the description or in the chat. So once this is done, we go to the next step, which is code generation. So this is going to be what I'll be focusing on for the rest of the webinar, because this is a feature I feel most teams don't make full use of, and it can really help you like quickly generate a CUDA-enabled node to your device, whether it's a Jetson or any other hardware device that you're using for your robot. So I'm going to be talking about coder configuration. So how you would want to configure your coder. If I switch to MATLAB, um, oh, right. So this is the train network that I had already trained using that video that I linked before. So you can see that it can detect these GUIs pretty accurately. And then talking about coder setup, I'm just choosing that we're going to be using a ROS2 node. So that's the hardware that's going to be here. And then the device type is going to be ARM64 because the Jetson Orin Nano that I'll be using is an ARM64 device. That that is what um, that's what mentioned here. We're going to build and run it onto the remote device. And you can see this four parts are basically your device configurations. So if you have your Jetson, you have to give it your IP address and the username and password. This way, MATLAB can SSH into that Jetson and then transfer all the generated code to the device. And you also have to mention where your workspace is located at. Mine is at Ubuntu ROS2 workspace. If yours was different, just mention that workspace in this field, hardware.ros2 workspace. So this should have your coder all set up and good to go. So I'm going to run this section. And then it's going to start editing the RoboSub ROS2 MLX. So this is a live script where we integrate the object detector model that was trained to a ROS function, to a ROS node, sorry. So you define the ROS node, and then I already have an image topic being published from a Jetson. It's one of the images taken uh, from the data set, and it has a red buoy on it. And then I'm gonna subscribe to that topic, which is under the topic image. So you can either have it like this, or in most cases, your images will be coming from your camera node. You might have a node that is taking the images from your camera and streaming it through ROS as a ROS topic. So you subscribe to that topic, and then we're gonna define two publishers, one that would publish the bounding boxes, and then the one that would publish the labels. Once you have that, there are other parameters that you need to define. One of them is the image size. This depends on the model that you use to train it with. So if it was a 416 by 416, that's what the YOLO 2 uses. That's what you define here. If your model requires a different size, just change it to that size. And then I'm using 30 hertz because I'm assuming most cameras publish at 30 hertz, and the Jetson Orin is capable of real-time detection. So it should not be a problem to detect at 30 frames a second. And then we'll go to the main loop, which is the body of the ROS node. It is going to receive this image and then read the data. And if the data is not empty, it's going to transfer it into this variable in, which I've defined here. So the reason that we have defined it to a different variable is because the coder requires variables to have definite sizes. So once you predefine the size here, you use that to get the data in. So the C++ function that is going to it knows what size to allocate. This is basically to make sure um, your code is efficient. So once that is done, we're going to use the predict function, which is going to, this is the predict function that we have written, which will just load um, the detector model that was trained before. Again, to see how the model was trained, please go to the video and you can see all the details on how the model was trained and how it was saved as a math file. So once that is trained, you can load that into a variable and then use the detect function, which would give you the bounding box, the scores, and the labels. Excuse me. So you take these values and then you populate the message fields with the values that you got from your predict function. So the bounding box message has the bounding box put into it, and then the label message has the label that is put into it. And then you just publish these data as ROS message. And before we go to code generation, you have to make sure your node first works. So what I'm going to do is I'm going to go to MATLAB and I'm going to run that function. But let me add a breakpoint here so we can see if it what kind of data it's subscribing to and if the predict function is working. So I'm going to call robo sub class2. Oops. Okay, so just see. Okay, so I'm just going to call it a different name. I'm assuming one of them is already running in this PC. I'm going to call it a different name. And that function. Right. So now we go into the function and you can see that it is subscribing to the image and it has made some predictions. We have a bounding box and then a label which says red buoy. So what you can do is you can do MG1. So this is the insert object annotation is going to take your input image and then draw the bounding box around it so you can see how it looks um, after your object selection. Actually, let me just show you how the input image looks like first. Um, I'm gonna see. Let's see how the input image looks, which is just a red buoy in the ocean, right? Or or a river. I'm not really sure what this is. So once you see it, then you can see how your object detection algorithm works by using the insert object annotation function. And then you can see that, which would highlight the buoy and then draw a bounding box around it and also give a label to it. So now you know that this has been published properly. So you can remove this breakpoint and let it continue. So this would be publishing it as a ROS message. And let me clear this. So I have an SSH connection to the Jetson that I have running here, and then it already has the image being published. Now it should also list all the topics to see if we can see what is being coming from MATLAB. So I'm just going to do raster topic list. Shows you the bounding box and the image topic. Bounding box and the label are being published. So I'll stop this now. Now that we know it's running, we can stop it and then start generating code from it. Again, just to make sure you don't see the bounding box or label anymore, so you know that the node's not running. So what you do next is so you know that the code generation should work because it works in MATLAB, right? So usually what we say is if it works in MATLAB, if you're able to do all this, then code generation should give the same results. So I'm going to go do code gen for the function robosubros2, which is what we wrote right here. And then I'm going to use the configuration that was defined here. So let me run this section. You can ignore this warning right now. So this takes a couple of minutes. It has to generate code, transfer it to the Jetson model, and then also compile it in the Jetson, all through SSH. So it takes a few minutes for it to compile. But in this minute, I can also take questions, or if you have questions or clarification, just put them in the chat. I can take them.
Like Abhishek mentioned, if you've got any questions, feel free to put them in the chat. You can always reach out afterwards and we can get back in contact with you guys to give any answers if you guys watch this after the fact. Don't have any questions yet, Abhishek.
Okay, I guess that's good.
So
But yeah, I'll just keep going, but feel free to interrupt me if there's any questions. And I'm also sorry about the light. It keeps turning off for some reason. Okay, so now we can see that code has been generated and then it's transferring that to the ROS device, which is the Jetson. And now it's starting to build, which is, I think it's Qualcomm build, right? So it's building it on the Jetson. So we should see it compile in a few seconds. And before that, let me switch to the presentation again. So we saw all of this. We are in the last step, which is to deploy it to a Jetson Nano. Once that is done, you'll be all set to generate your own CUDA node into your ROS device. So this should help you when you go out there in competitions or hackathons. You can all do it very quickly with MATLAB. Just get all the labels, train your model. Again, you can even train it in Python if you're comfortable with it, and then use the trained model in MATLAB to generate a ROS2 node. So that we also integrate very well with Python and C++. So that should not be a problem for you to do. So while it compiles, I also want to briefly touch on something exciting that we have coming. So Robot X is a competition that's held by RoboNation. It's a super popular competition with teams all over the world. You might have probably heard of it. Some of you might already be participating in it. I just want to let you know that MathWorks now has introduced a new design award that is worth $2,000, and it should be going on from this year. So you have um, three prizes divided 1,750 and 250, I think, and the total worth is 2,000. And we are mainly looking at how you use MATLAB or Simulink to design your robot or any part of your robot algorithm. Stay tuned for this. I'm sure RoboNation and MathWorks too will reach out with more details so you can see what's the requirement to participate and how you can get how you can compete in this award.
And as Abhishek mentioned, we'll be sharing more details about that soon. And for those of you that are registered for the Robot X Challenge this upcoming November, we'll be sharing more details about that during our team times and then directly over email to all of you.
Yep. So stay tuned for that. Let me go back to MATLAB to see if it's done generating code. Okay. Right. right? Okay, so this is a warning that you can function. It's an infinite loop because it keeps on subscribing to the image. But you can see that code generation was successful and was generated into the Jetson. To view that, just go back. Going back into the SSH terminal I have. I'm gonna list all the topics. You can see that bounding box and labels are back because it's now running on the Jetson. And you can also echo the topic to see if it's the same result, which is a red buoy with a bounding box. Right? So you can see that red buoy is being published. You can also echo the bounding box. And you get all the data published in your ROS topics. So you can then use this to feed into your control algorithm for navigation or obstacle avoidance, and then work just integrate it into your workflow as you go to the next steps of your competition. Back to presentation. So that's about the MathWorks award and how you do code generation with MATLAB for an object detection model. That's all I have for today. If you have any questions, you can also email it to roboticsarena@mathworks.com. We usually get back within a day, so you don't have to wait for long. And if you need access to these files that I've been using, if you need access to any of the code, feel free to reach out via this email, and I can share it with you anytime. Or you can also reach out to RoboNation, and then I can send it over to them as well.
Like Abhishek mentioned, you can reach out to that email. The link for that is also in the chat and in the description of this video as well.
Great. Is there any questions? Sorry, Alicia, you muted.
We do not have any questions in the chat right now.
Okay.
So no questions as of yet.
Okay, that's great. But feel free to ask questions again. Just send an email to us. Don't Even if it's like something small, we will still get back to you. So don't hesitate to send out an email.
Absolutely. Thank you all so much for joining us today. We're really excited to kick off this year's MathWorks mini-series, and we look forward to our next session, which will be on May 16th, also at 11 a.m. Eastern Time. So we'll be sending more information out about that, as well as some of the fun stuff that Abhishek spoke about today. And then for those of you that want to share this link and any other information about this webinar or the future ones, I will be sending out a follow-up email this week about this webinar and sharing that link as well. So thank you so much for joining us.
Thank you.